So in the demonstration video you saw that a donkey got pruned. However, in the tutorial we're going to use the actual monkey model so that you can see that this pruning effect works on any mesh. So I added in this monkey with a subdivision surface level on 2 so that we have enough geometry to prune. I also added in this empty, which I called the pruning controller, because this empty is going to control from where the object will start pruning. So from here, let's get started by going into geometry nodes. Let's click on the monkey and create a new geometry nodes for the monkey. And the first thing that we want to do is finding the vertice on this monkey that is the closest to this empty. So what we're going to do is taking this pruning controller and drag it into our geometry nodes so that we have the location of this empty in our geometry nodes. And from here we also want to take a position node so that we have the position of each vertice of this monkey. And to get the distance from each vertice to the empty, we can do a vector math node which we set on distance. And then if you connect them both, we're getting the distance from each vertice to this empty. And now we want to find out which vertice has the minimum distance to the empty. And we do this with an attribute statistic node. And the geometry of this is going to be our original monkey geometry. So like this. And the attribute that we want to get the minimum value of is this distance value. And then we can say with a compare node, which we set on equal, we can say, okay, which vertice has the same distance as the minimum distance of all vertices. And now if we do Ctrl-Shift-Click on this one and Ctrl-Shift-Click on this one, we can see that is this vertice. And if you move this empty around, you will see you can now basically start selecting from which vertice the object should start pruning. Now this white value over here, we basically want to blur those colors out so that it kind of expands. And this, we can do that with a blur attribute node. And if we set that over here, and if you set the iterations higher, you will see you will be able to blur this value out, which is pretty cool. So now this blur attribute value, we want that to control a delete geometry node. Because if we put this value into the selection and we remove the viewer again, then you will see with the iterations we can basically prune the object already. However, you will see that if we prune everything, you see the eyes of the monkey are still staying there. And the reason for that is because none of the vertices of the eyes is connected or linked to the vertices of the body of the monkey. So to fix this, we can go into edit mode and just take one vertice of the eye and one vertice of the body and press F to fill it. And then do that for the other eye as well. So take this one, for example, and then shift click on this one and press F to fill it. And then you will see the eyes will also get pruned with the whole thing. Because now the blur attribute node can actually blur the value to the eye. Otherwise it's not possible. I don't really like that the pruning part goes so blocky, right? I want that to go a little bit smoother. So what we want to do is to smooth out the position of each vertice. So if you do a set position node, set that like this. And then we take the position of each vertice and with another blur attribute node, we want to blur this position out. So we do a vector because the position is a vector. And if we connect that like this and then connect it like that, then you see it already gets blurred out. If you want this to be even smoother, you can set the weight value over here to 20 and then it goes like this. And now we have a very smooth transition of pruning. In the Loki series, when they prune someone, there's always like a glow of light around the edges of the pruning part. So let's add that in. And I want to add that in by making the edges that are like over here to convert those into curves and make them thicker. So the first thing we have to do is separating this edge from the rest of the monkey. And we're going to do that by creating another blur attribute over here. But this new blur attribute, I always want that to be a few iterations further than the original blur attribute. So let's make some space over here and let's add in another blur attribute and connect equal with the value as well. And then let's make it that this blur attribute is always one iteration more than this one. And we do this by adding in an integer. Let's set this now on 6 because both of them are already on 6. So let's leave it like that. Let's connect it with both. And then for this one, I want to make it with a math node. You can add 1 to it so that it will always be 1 iteration further. Let's preview this. So if we do Ctrl-Shift-T on this blur attribute and Ctrl-Shift-T on this one, then you will see that if we now also do Ctrl-Shift-T on this one and we switch, then you see the blur attribute is always a little bit further. So if we now add in a mesh to curve node, and as the selection, we put this blur attribute. Now if we delete the viewer, you see it's all gone. That's because this data, it's not really going to work. In order to make this work, we have to capture this attribute from the original monkey. Otherwise, it's not going to work, because now it's kind of messing with the delete geometry that this is not working. So if we add in a capture attribute node and we plug in this attribute right over there, and then we plug in the capture attribute in the mesh to curve, we're always getting the end edge of this pruning part. And then this, we can give that some thickness with a curve to mesh node. And as the profile curve, we do a curve circle, set that like this. Then you see, boom, it becomes very big. Just set the radius a lot lower so that it goes like that. And then you will see if you control this integer value over here, you will be able to go around the whole monkey, which looks pretty cool. Of course, we want to combine this curve thing with the original mesh, right? So if we do a join geometry, we can plug in the curve to mesh, and we can plug in this set position node right over there and connect it with the group output so that we're getting this result, just like that. From this curve object, I want that a lot of particles are going out of it, like fireworks, something like that. And to do this, we're going to use simulation nodes. So the first thing that we're going to do before we do the simulation nodes is distributing a lot of points on these faces. So let's do a distribute points on faces node and connect the curve to mesh with the distribute points on faces. And let's preview this. Let's set the density value on 500 for now. Later you can make this any value that you like, just play around with it. And these points, I want to simulate those that they are like pushed away. But before we do the whole simulation nodes thing, it would be handy if we animate this integer value. So let's say on frame 1, this integer value is a -1, so that there is a nothing, and press I to insert a keyframe. Then go to frame 50, for example, and make this bigger to go around the whole thing. And once the monkey is all gone, you can press I to insert another keyframe for this integer value. And now if you press play, you're getting this. Cool, from here we can do the simulation zone. So let's add in a simulation zone. And if we connect the distribute points on faces like this and the simulation output like that, if we now press play, then we don't see anything. That's because the simulation zone now only takes into account the points that are visible at the first frame of our animation. But we don't want this, we want to have all the points, right? So instead what we're going to do is don't connect it over here, but we're going to connect a join geometry right in the middle, and then connect the distribute points on faces like this to the join geometry. And then if you press play, you will see it works. However, the points are staying there, right? And we want that the points start flying away. And to do this, we need to have velocity for these points. So in the simulation input, I want to import a velocity attribute. So click on the simulation input and click over here on this plus icon and name this velocity. And this should not be geometry, of course. No, this should be a vector. So now we have a beginning velocity for these points. But to actually make them move, we're going to need a set position node, and then connect the velocity with the offset, and also this beginning velocity with the end velocity, so that it can update over time. Right now it doesn't do anything, of course, because the beginning velocity is 0, 0, 0, and we're not changing anything to it. But let's make it that the beginning velocity is actually the normal direction of each face that is distributed on, so that it will push outwards. And we have that normal direction right over here in this distribute points on faces. So if we connect that with the velocity like this, then you will see it still doesn't work. That's because it now only works for the points that are visible in the beginning. To make the normal direction also work for the other points that are added in later, we have to add in a vector math node. Keep this on add, and we want to add the same normal direction over here, and then you will see it will start pushing out. A bit too fast, of course, so let's slow it down a little bit. If you have the Node Wrangler add-on, you can do Shift and right mouse button to connect these two parts like this, and then you can add in a vector math node right over there. Set this on scale, and now if you scale it down by 0.1, you will get this, so that it goes a lot slower. However, right now they all have the same beginning velocity, and that's not really good, right? I want to randomize this beginning velocity. So let's do a random value node and connect that with the scale like this and set the maximum value on 0.1, for example. And the minimum value, let's do that on 0.01. And then we're getting random velocity for each point. Now I also want to add in some gravity, of course, because these points are not in outer space. So let's take this vector math node and let's press Shift T to duplicate it over here. And let's make the Z value minus 0.01. And then if you press play, you will see they will start falling down. Now you see the points are going into oblivion and they never disappear. But in reality, these sparkles should like disappear after a while. So basically what we want to do is we want to track the age of each particle so that we can say, okay, if the age of each particle is higher than a certain value, delete it. So let's track the age first. And we do this by creating a new attribute by clicking on the simulation input and click on plus over here and make this age. And this age value should be an integer. And then to track the age of each individual point, you want to do a capture attribute node. Set that like this and set this from float to integer and connect age with the value and then attribute with age. And now we're already tracking it. However, right now throughout the simulation, the age stays the same, but we want that each frame, the age goes up by 1. So if we do a math node, and we set that like this, we can add 1 each frame to the age of each value. And now if we make a little bit more space over here and we do a delete geometry node, we can make as the selection a compare node, which we keep on greater than, but we can put it on integer. And we connect the age like this, and then the result like that. And now we're basically saying, okay, if the age is greater than, for example, 20 frames, delete it. So now it looks like this. You see they get deleted right over there. I think we can even make this lower. So let's make the B value 10. And then it looks a little bit better. However, these points are now just points and not real objects yet. So let's replace each point with an icosphere. And we're going to do that by doing instance on points node. And as the instance, we want to do an icosphere. Let's connect that like this. They are way too big, of course, so let's make the scaling smaller over here. And actually, I want to do a random value for this. So let's do random value, connect it with the scaling, and let's set the maximum value lower, kinda like that. That you really have small particles that are shooting out of it. And now if we combine this with the rest by adding in a join geometry over there, and we connect this join geometry right over there, then you will see if you press play, you're getting a cool pruning effect already. Now the last thing that I want to add in is kind of like when it prunes, the object turns kind of in a blue foggy thing. So to do this, I want to make it that this curve object leaves another set of points, but this set of points will create like a foggy cloud around it, which then slowly dissolves over time. So let's do this. Let's do another distribute points on faces by clicking on this one and do Ctrl-Shift-D so that we keep the connection with the curve to mesh. We can keep this one on 500 and let's do a simulation zone again. And again, for this simulation zone, we don't want to connect it like this. No, we want to do a join geometry node so that we can connect the distribute points on faces like this. And then let's do Alt-Shift-Click on the simulation output so that we can preview it. And then you see we have the same as before. But this time I don't want them to sparkle around. No, I want them to become very small, then grow, and then become small again. So we're going to affect the radius of each point. So we want to add in the radius of each point as an attribute in the simulation input. So let's click on plus over here and make this radius. And let's make this a float value. And let's connect this radius with this radius so that we can update it over time. And we also want to do a set point radius so that we can update the radius of each point, of course. And connect this like that. And to get the radius of each point, we want to do the same thing as with the age tracking that we did earlier. So we want to do a capture attribute node and connect the radius with value and then attribute like this. So that we're actually tracking the radius of each individual point. And to this attribute, I want to do a math node so that we can add each frame, we can add a certain number to the radius of each point so that it looks like this. Now you see, yeah, they become way too big, way too fast, of course. So let's make the add value 0.05. so that it goes like this. But now you see they grow, and they don't stop growing, right? But I want them to grow and go back again. So what we do is first, let's make a little bit more space like this. And I want to manipulate this line over here with a float curve node. And with this float curve node, we can say, okay, it goes from 0 to 1 over here. So at 0, I want it to be a radius of 0. And at 1, I want it to be a radius of 0 as well. And in between, it should be a higher radius. And now it looks like this. You see, they do become smaller, but it's not really visible because they still become way too big. So let's do a math node right over there and set this on divide. And divide this by 20, for example, so that we can see it a little bit better. And then you see it becomes this effect. And now these points, I want to convert those into a volume. So if you do a point to volume node, then you see we're already getting a huge cloud, right? But let's set the resolution on size. So let's set the resolution on 0.02 so that we have a little bit more resolution on our volume. And as the radius over here, I want to use the radius of each point. So basically what we have to do is do a radius node and connect that with the radius. And then we're getting this pretty cool effect of fog going like this. Perfect. Let's combine this with the rest. So let's connect this points to volume node with the last join geometry and then connect the join geometry with the group output. And then you see this is the effect that we're getting. So we have sparkles, we have fog, and the whole thing dissolves. And the cool thing is we can still change the position of this empty like so and then play it again and then it will dissolve from there. The final thing that we have to do is creating the materials for these. So let's first do the glowing material, and the glowing material will be assigned on the sparkles but also on this tube part right over here. So let's go into material preview mode and let's split our screen in half like this and go into the shader editor and then click on new to create a new material, and let's call this emission material. So let's remove the principal BSDF and let's add in an emission shader and connect that like this. But then you see it does it on the monkey and not on the actual tube part and the particles. So what we have to do is we have to assign this material to the right parts in geometry nodes. So let's add in a set material node over here. And this set material is going to be the emission node. And let's connect that like this. And let's shift D this and connect it also over here between this curve to mesh and the join geometry, because then the curve part also gets it. And then to assign a completely different material to this monkey, you can take this set material, duplicate it to here and remove the emission, and then later you can add in any material that you like for it. And now the material is on the right objects. And what I think would be a cool effect to do for this emission material is to do a layer weight, connect facing with color, so that we're getting this cool gradient effect. And then if you connect a color ramp, connect it like this and make the black value brighter and more like this, and make the white value more yellowish so that we're getting it like that. Then you see if you set the strength higher to like 50, I think this would be easier to see if we turn on bloom over here. Yes, that's a little bit better. Let's make the yellow part a little bit less saturated, so more like this. Yes, that looks good. That looks really good. Let's give every particle a random strength of emission. So let's do an object info node and let's connect random with the strength. Then you see, yeah, it works. They all get a random strength. However, we want to have this brighter, right? So now this random value goes from 0 to 1, but I want to make this that it goes from 0 to 50, for example. So let's do a map range node, set that over there. And now it goes from 0 to 1. Let's set this from 0 to 50. That we're getting this. And then if we press play, it already looks a lot more alive, so to say. Now for the materials for the volume parts, let's click on plus over here to create a new material. And let's do volume. And let's remove the principal BSDF because we want to do a principal volume and connect that with the volume. And now this volume material, we have to of course assign that in geometry nodes. So let's do a set material right over here after the points to volume, and let's make this the volume. And the thing that I want to manipulate the most in this principal volume is the emission strength and the emission color. The emission strength, if we set this on 1, then you will see, boom, it goes like this. That's not really good. So we should not make this 1 because then the whole thing will be 1. What we want to do instead is add in a volume info node. And then we have this density socket and connect that with the emission strength. And then you will see we're getting volume right over there. This whole thing might look a little bit better if we go into cycles, of course. So let's go into render properties and set the render engine on cycles. And let's turn on GPU if you have a graphics card. And let's go into render view mode so that we can see the smoke a little bit better and a little bit more realistic, of course. I want to add a little bit more noise to the density of the smoke so that it's not so uniform, right? So let's do a noise texture and do Ctrl-Shift-Click on it, and let's make the scaling 2 so that the noise becomes a little bit bigger. And then let's also add in a color ramp right over there, and let's make this a little bit more contrast like this. And then I also don't want that it goes so sharp, right? I want to have it a little bit softer, so we set this from linear to B-spline like that. And then this, we want to multiply that with the density value that we have now. So if we do a math node and we set this on multiply, we can connect that like this. And now if we disconnect the noise texture from the surface, we can see we have noise, kind of. It's a little bit hard to see, but it is there. To make it a little bit better to see, we can multiply this noise texture so that it becomes a higher value. So if we take this multiply node and we put it over there, we can multiply this by 10, for example, so that we can see it a little bit better. Now I want to make this not white, of course, but I want to make this like blue-purple-ish. So for that, we're going to do another noise texture, from which we're going to connect the vector with the emission color. And then for this one, we're also going to make the scaling 2, and we're going to add in another color ramp. And for this color ramp, I'm going to change the black part to be more greenish and the white part to be more purple-ish. But now you will see this color value. So from this color to this color, it will go from here straight through the white to there, right? But I want this to go from this point clockwise to this point. So to do this, you can set this from RGB to HSL. And then don't set it on near, but set this on clockwise. And then we'll see that it will go from here to here in a clockwise way, which gives this pretty cool noisy blue purplish effect. And believe it or not, to make it look better, we want to set this density value to 0 so that we don't have smoke and only have the emission parts. And then if we press play, it will look like this, which looks pretty magical, to be honest. However, there are still a few things that we need to fix. Because if we turn on motion blur over here and we press F12 to render this, yeah, then you might be seeing a lot of glitchiness in your particles, right? And you might think this is a bug or a glitch, but actually it is not a glitch. What is happening now is this. Each particle gets an index when it gets emitted from the monkey. But each time a new particle is added in, the other particles are getting a new index. And this messes up the motion blur so much that it goes crazy like this. So we want to tell Blender, okay, each particle when it emits, don't change the index or ID anymore. So we have to do this for both simulation zones by adding in a set ID node and connect that before the join geometry and between the distribute points on faces. And the ID value that we want to have over here is a random value, which we set on integer and just make this a very high number. So that we just assign a completely random number to each particle, which it will keep throughout the whole simulation. So if you connect it like this, and now to make it even more randomized, we can make the seed value dependent on the scene time by connecting the frame with the seed. And now if we take these three nodes and shift D them to this simulation zone, and we connect distribute points on faces like this, we disconnect this one and we connect this one. But then it still won't work, because if you do it like this, you will still have particles that have the exact same ID. So in this one, we're going to do a math node, and we're going to add a high number to this, so that now if we press F12, then you will see it looks really good, and the motion blur just works as it should be. Another thing that I recommend you to change is the resolution in the curved circle. You can set this on 6. For example, just to save some computer power. Another thing that I would like to fix is that if you're going to frame 0, the frame on which the integer value is -1, then you will see we always have a hole in our thing. It's already like a pruned a little bit. And we don't want that. We want that when this is -1, that this thing should be the original mesh. So what we're going to do is making a little bit more space, and we're going to manipulate these two values. So if you hold down Shift and hold down right click and make a joint over here, you can do a mix node, and we want to make float A to be this one and float B to be 0. Now we can do a compare node and set this on integer, and we can say, okay, this integer value, if it's equal to -1, then it should be B. And if it's not equal to -1, it will be A. Because now if you press play, you see it still works, but then at frame 0, you don't have any pruning. So now that we know how to prune objects in Blender, we can start working for the TVA, and also we can give this video a thumbs up, comment down below if you have any questions, and if you want to support the channel and you don't want to miss out on any future videos, I recommend that you hit the subscribe button. And with that being said, I see you in the next one.